Find the right code snippet fast with BM25+Embeddings. By the end, you will have a working hybrid search pipeline in Python. You will see how lexical BM25 ranking and simple token embeddings combine. You will also learn a trick that flips results with a tiny query expansion. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Hybrid code search improves relevance, which is our core metric. BM25, the classic scoring function, optimizes exact term relevance by combining term frequency and inverse document frequency. Embeddings capture semantic overlap and help when words differ but meaning matches. The trade-off is clear. More semantics costs memory and compute, while pure BM25 is cheap and precise on exact matches. At scale, you might measure gains in NDCG or precision at 10 on corpora of thousands to millions. Think of BM25 as a smart keyword matcher and embeddings as a soft meaning matcher. Together they shine when queries mix exact names and intent. A limitation is calibration. You must balance lexical weight against embedding weight, where one signal will dominate. Now we will build a tiny pipeline that demonstrates tokenization, BM25 scoring, embedding-like set similarity, hybrid blending, and a simple query expansion. We will build a 4-document example and show how the top result changes when we blend signals and expand the query. This snippet tokenizes a tiny corpus and shows query terms found in one document. The tiny list docs holds 4 short texts, and Q is the user query. The tokenizer, named Tok, lowercases text and extracts letter-only tokens, producing 2 lists called Toks for documents and Q for the query. The code then compares the query tokens with document 3 using a set intersection to find overlapping words. The sort call only orders the results for readability. The printed overlap confirms the tokenizer is working and which query terms are present, which is the foundation for any lexical score like BM25. Now we'll score documents with a compact BM25 style routine. This snippet ranks the documents using a compact BM25 scoring routine. The dictionary IDF stores inverse document frequency values for each term in the query set, which rewards rarer and more discriminative words. For each document, a saturated term frequency fraction scales matches, so repeated tokens have diminishing returns, then multiplies by IDF and sums across query terms to form a BM25-like score. The code creates pairs of document index and score and sorts them in descending order to produce the top 3 documents. Because a very high IDF term that does not appear contributes nothing, the ranking reflects actual matches, and the printed list shows the most relevant documents and their BM25 scores. Next, we'll compute a simple embedding-like similarity using token sets. This snippet computes a token set embedding similarity with Jaccard scores to mimic a semantic signal. The helper grams turns a token list into a set, which is our simple embedding per text. The numerator counts shared tokens between the document set and the query set, while the denominator counts unique tokens across both, yielding a normalized overlap between 0 and 1. We compute these similarities for every document and then sort to produce the top 3 candidates. This set-based measure is fast, robust to repeated tokens, and gives a different ordering than BM25 when documents share many unique tokens. The printed tuple list shows which documents share the greatest proportion of tokens with the query. Now we'll blend both signals into one hybrid rank. This snippet blends BM25 and embedding scores into a single hybrid ranking. The list B25 holds each document's BM25 score, and we normalize it by the maximum, so both BM25 and the Jaccard component land on a similar scale. The code computes the Jaccard set similarity inline for the embedding signal and forms a weighted sum using alpha to control the trade-off between lexical precision and semantic overlap. Increasing alpha favors BM25 precision and tight keyword matches, while decreasing alpha gives more influence to the embedding and can reorder ties or surface semantically related documents. The printed top results show the hybrid ranks and their blended scores. Finally, we'll try a tiny query expansion and watch the top hit change. This snippet adds a simple query expansion and compares the top result before and after. We extend the original query tokens Q to a new list Q2 by adding the word ranks to capture a variant that appears in one document. The BM25-like component is recomputed on Q2 using the same saturation and then renormalized on the fly, so scales remain comparable. We keep the same embedding similarity and alpha value and then select the index with the highest hybrid score. By broadening the query, a document that contains the added variant gains extra credit and can overtake others. The two printed numbers show the previous best versus the new best and illustrate that clear shift. Recap in 3 points. Hybrid search combines BM25 lexical precision with embedding style semantic overlap. Use it when queries mix exact identifiers and intent, or when synonyms matter. One caveat is calibration. Blending weight and query scope change results significantly and need validation on your data. Next step, tune the BM25 parameters K1 and B to see how ranking sensitivity changes. Or measure NDCG on a larger corpus while adjusting alpha. If you want practical IR that scales, subscribe and watch the rest of the IR videos.